Welcome to today's deep dive. Today, we're actually looking at a piece of hardware that acts as the invisible spine for high-end AV setups and smart buildings. You sent us the spec sheet for the Zenty ZT-420.
The 48-port AV-over-IP PoE Gigabit network switch, right?
Yeah, exactly. From HDTVSupply. Quite the mouthful. And while a spec sheet might seem, kind of dry on the surface, the engineering packed into this single piece of metal is pretty wild. We're going to break down how this specific combination manages to move an incredible amount of data and electricity at the same time without buckling.
Right, because when you're building out enterprise security systems or deploying dozens of synchronized displays across a huge venue, you simply cannot afford a single bottleneck. And looking at the numbers on the Zenty switch, they've clearly engineered it to eliminate those choke points right at the hardware level.
Okay, let's unpack this, because the power delivery is what caught my eye first. It's a 48-port gigabit PoE switch, but it boasts a 550-watt total power budget. For a 1U rack-mountable device, that is a serious amount of electricity to be pushing.
It really is. Since you already know the value of power over Ethernet, we don't need to harp on the convenience of dropping extra electrical outlets. The real story here is the thermal management.
Because it's acting like a massive traffic cop for internet data, but it's also the power grid.
Exactly. Pushing up to 30 watts per port across a highly dense 48-port layout, while confining that to a 1U chassis, that generates a lot of heat.
Right, you're running high-draw devices like pan-tilt-zoom IP cameras, high-end wireless access points, or entire VoIP networks, all drawing from that central 550-watt pool.
And keeping that power delivery stable is crucial because of the data payload riding right alongside it. If the voltage fluctuates, you risk packet loss. Which brings us to the data routing side of the equation.
Yeah, let's get into the switching capacity. The spec sheet lists 176 gigabits per second backplane.
What's fascinating here is that it's non-blocking. That's the key term. 176 Gbps switching capacity means even if all 48 ports are firing simultaneously at full duplex, the internal fabric of the switch won't drop a single frame.
So it can handle the absolute maximum theoretical load without creating an internal traffic jam.
Right, and to get all that aggregated data out of the switch, they've included 4 10-gigabit SFP plus uplink ports.
Which opens the door to fiber optic connections.
Exactly. That's where the enterprise-grade nature of this really shows. When you're wiring a corporate campus or a huge digital signage network, standard copper Ethernet starts to degrade over long distances. Fiber uplinks mean you can push 40 total gigabits of data back to the core network over incredible distances with zero latency.
The specs also mention a store and forward architecture, so it's basically doing error checking on the fly.
Yeah, it receives the entire data packet, checks it for corruption, and only forwards it if it's clean. When you are pushing uncompressed 4K video over IP, a corrupted packet means visual artifacts on the screen. The switch is essentially acting as a high-speed quality control inspector.
And it's keeping track of a staggering number of devices while doing all of this. The MAC address table on this unit holds 32K entries.
32,000 unique hardware identifiers. To put that in perspective, an average home router might keep track of a few dozen devices. Even a standard small business switch might only handle 4,000 to 8,000 MP addresses.
So why build a 32K table into a 48-port switch? You obviously can't plug 32,000 devices directly into 48 ports.
It's all about downstream networks and complex virtual LANs. In a high-density environment, this switch might be sitting in the middle of a sprawling topology, routing traffic from dozens of other connected switches and wireless networks. It needs the memory capacity to instantly recognize and route data to any device on the wider network without having to pause and ask directions.
So what does this all mean? Bringing this back down to the bottom line, this unit retails at a $700 MSRP. For 48 gigabit PoE ports, 10 gig uplinks, and that kind of enterprise-grade routing capability, it really highlights how accessible this tier of infrastructure has become.
If we connect this to the bigger picture, it changes the math for system integrators. You are converging your physical power distribution and your high-speed data routing into a single, highly efficient layer. It completely streamlines the deployment of complex systems.
And that's exactly why understanding these specs matters to you. Whether you find yourself auditing an office tech upgrade or you're just sitting in a sports bar marveling at how 50 displays are perfectly synced to the exact same millisecond of a game, you now understand the specific hardware capabilities running the show behind the scenes.
This raises an important question, though. As our infrastructure increasingly relies on these single centralized devices to deliver both critical data and physical electrical power simultaneously, how will this all-in-one approach fundamentally change the way we design, wire, and build the physical spaces of the future?